Now we're going to look at domain and range. I've got some important definitions that you'll need to know and understand because they'll be popping up throughout this course, and if you have to take another math course, you'll hear it there too. The domain of a relation is a set of first coordinates of the ordered pairs in the relation. If you remember your ordered pairs, you have parentheses x comma y. So it referring to the first coordinates, it's referring to your x values. There are some x values that are not legal values for substitution and are therefore excluded from the domain. We cannot divide by 0, and in this course we do not look at imaginary numbers, so that means no negatives under an even root. The range of a relation is the set of second coordinates of the ordered pairs, which means your y values. A function is a relation in which no two different ordered pairs have the same first coordinate. So I've got two different points. I cannot have the same x value in the two different points. A visual method for determining whether a graph of a relation is a function is called the vertical line test. So if you're given an equation where y is raised to an even power, you will not have a function, and we'll look at that in just a second. So let's look at these problems. I am going to get me a vertical line. And I'm going to make it a little bit bigger. That's a good vertical line. So I'm going to move my vertical line and see if I can hit this picture in more than one place. So I'm going to shift it over, and if you'll notice, I can. Let's look at this right here. Notice I hit this curve at this position and at this one. Let's say this is an x value of -2. This point on the curve, say it's -2, 1, and the point down here is -2, -2. I've got two different points, but I have the same x value. So you see, this relation is not a function. And that's all I have to do with a vertical line test, is try and do my best to hit the curve in more than one place. Now let me move this on over and see about this one. Notice I can only hit it in one place as I go throughout this curve, and assume that on the ends here I've got arrows, okay? And if you'll notice, all I could do is hit it once. So for one x, I've got one y. So b is a function. What about c? All I have to do, I don't have to shift it through, just do my best to do one vertical line and hit it in more than one place. So I can hit it here and here. So this is not a function. Let me move it down here. What about this one? Do my best, and I only can hit it in one place. So D is a function. What you think about E? I'll stop it here. Hit it in two places. It is not a function. What about F? Can you imagine that line going all the way through? And I can only hit it in one place. So F is a function. So to recap, A, C, and E are not functions, whereas B, D, and F are. Now what if you're asked to graph on your calculator to determine if y is a function of x? Well, I've got to solve the equation for y if necessary. So in number 1, let me get my calculator up. I need to add 7, so I'm going to have x squared plus 7. Let me graph it. So it's way up there. Let me change my window just a little bit. I need to change my y's. Let me do 0, say, to 20. Let me graph it. So if you can imagine that vertical line coming through, I can only hit it in one place, so number 1 is a function. Okay? Now, 2. We got to look at number 2. Earlier I said, right here, if given an equation where y is raised to an even power, you will not have a function. Well, let's see why. I've got to solve for y. If you remember to get rid of a square, I take square root, but also remember I need to do something over here when I take square root of both sides, and that is use plus or minus. So square root of y squared is just y. So I've got y is equal to plus or minus square root of x plus 1. So let me go back to my calculator. I do not have a plus or minus key on this calculator, so I have to do the plus version. So let me do square root x plus 1, and then a negative square root x plus 1. Let me ask it to draw, but if you remember I changed my window, so if I do zoom 6, it will recenter. So, is this a function? If you do a vertical line right here, no, it is not. And that's why I said if you've got y raised to an even power, be careful. Let's see, what's our next one? Whoopsie. Absolute value of x. Well, let's go back to y equals. Let me clear that one and that one. Remember, absolute value is under math, under the number, and hit enter. So I had to go to y equals first, then go to math so I could paste it. Let me put my x in. Let me ask it to graph. Sort of looks similar to D, and if I use my vertical line test, if you'll notice, I only can hit it once. So number 1 and number 3 are functions, whereas number 2 is not. I've got to grab my line. We've got a little bit more to do, and I need this on the next page. Okay, this is a domain worksheet. You're going to have to graph the functions, and then scan left to right on the x-axis, and then give the domain using interval notation. I've added also the range. So first thing we're going to do is go through and look at domain. Now, if you put this on your calculator on Zoom 6, you should have this picture. And also, maybe in the next TI they'll put arrows, but for right now you have to imagine. Now, when I use this, I use it sort of like a scanner. You've seen copiers and you've seen fax machines where you've got a little light and it goes through. Well, that's what we have to do with this when we look at our domain. Remember, domain is x values. So I'm going to scan my x-axis. Now, if I run into an arrow right here, that means negative infinity. Notice I'm coming from that direction. And if you exit hit an arrow, that means positive infinity. Because in this particular curve, I can use all x values. So my domain, using interval notation, is negative infinity to infinity. So let's go to my next one. Graph it and see if you have that picture. So as I come in, I don't hit the curve, but if you'll notice, it just all of a sudden starts right here at -3. Oh, pooh, stop that. Okay, now when your curve goes out of the picture, that's when I need you to imagine an arrow. But when it all of a sudden just starts, that means that is a usable x value, but there are none here. Earlier I said I cannot have a negative in under the radical, an even radical, because in this particular course we still stay in the real number system. So if you count, it looks like I start at -3. And if you put -3 in, I have square root of 0, which equals 0. That's a legal number. So as I scan through, I hit -3, and I exit hitting the imaginary arrow. So it looks like -3 to infinity, but since this is a usable value, I have a bracket. Okay, let's look at these other ones. Let me pull my line down here. So as I come through, I hit coming in. It's an arrow there, so that's negative infinity. And it looks like I go up to about this value. And if you'll notice, there is an actual physical break. Those of you that have 83s, you'll actually have a line here because your calculator is in connect dot mode, and it understands that you want it to connect. They fixed that in the 84. 84 is your picture will come out like this. But since I have a physical break at 8, if you'll notice, if I use 8 here, that's division by 0. That's a no-no. I cannot use 8. But I can use any other x value as I go on out. So my domain will be negative infinity to 8, which I can't use, and then 8 to infinity. You use a union for an OR because you're indicating the usable x values. Well, let's go over here. As I come through, I hit an arrow here. I exit, hitting an arrow here. So my domain is negative infinity to infinity. Get my vertical. As I come through, I hit an arrow, exit, hitting an arrow as I scan the x-axis, which is for my domain. So this one's also negative infinity to infinity. Okay, this one's wild. Notice I've got breaks. And if you count, 1, 2, looks like negative 3 here, 1, 2, 3 here. So if you put negative 3 or 3 in here, you're going to have division by 0. Those values have to be excluded. So let me get my little vertical scanning bar here. I hit the curve, so negative infinity, break, can't use that. Keep going through, those are usable x values, break, can't use that. And I exit, hitting an arrow. So if you can imagine, negative infinity to negative 3 in parentheses, union, negative 3 to 3, in parentheses, union, another parentheses with 3 to positive infinity. Those are my usable x values. Now range, if you remember, are my y values. So let me move back up. I'm on. Let me see if I can change this to this scan. That's cool. Alright, as I come up, notice I always start in the negative direction. I hit the arrow, negative infinity. I go through positive infinity. So my range, like my domain, is all real numbers. Let's try this one. I don't hit any negative y values. I don't hit a y until right here on the x-axis, and on the x-axis is a y value of 0. And as I scan on out, I hit an arrow, which means positive infinity. So I should have bracket 0 to infinity. If it's usable, you have a bracket. If it's not, you have a parentheses. So let me get it down here. So let me scan going up. Okay, I hit an arrow right here. That means negative infinity. And right now it looks like I have got a break right here. Let's move it on up at a y value of 0. Okay, that's what it looks like. So that's what we're going to go with right now. And as I keep going on up, I exit, hitting the curve for my y values, going toward positive infinity. So let's see, negative infinity to 0 and 0 to infinity. Okay, let me get my little horizontal scanner. As I come up, it looks like I hit at negative 7, right in there. So it is a usable value, and I scan on up, exiting positive infinity. So my range should be a bracket negative 7 to infinity. A couple more scans and we're done. I hit an arrow, negative infinity. I hit another arrow right here, positive infinity. So this one's all real numbers. What about this one? I hit an arrow here. Okay, so negative infinity. And if you'll notice, this curve, as my x's get real small or real little, levels off, but just this middle piece, I'm using all my y values. So my range will be all real numbers, or negative infinity to infinity. Okay, that's it for this one. Thank you.